So from x belongs to 0 to 1, so we will modify the expression and we will check whether we are getting positive or not, the value of expression positive or not. So here x raised to 12 minus, this is x raised to 12 minus x raised to x raised to 9 plus x raised to 4 minus x plus 1. See, if we take here common as plus x raised to 5, so we can write down this expression 1 minus x raised to 5. Here 4, I am taking 4 common, x raised to 4 I am taking common, and plus this expression we can write on 1 minus x, right? So for x belongs to 0 to 1, this is positive. As you can see, if x belongs to 0 to 1, x raised to 5 will be less than 1. So 1 minus something which is less than 1, that is also positive. Here 1 minus x, that is here x belongs to 0 to 1. So if x belongs to between 0 to 1, so this is also positive, this is also positive, this is also positive. So from x belongs to 0 to 1, the expression is positive. Now let's see from 1 to infinity, right? If x belongs to 1 to infinity, so x raised to 12, again we will try to modify the expression. So this is x raised to 12. Now if I take here common, x raised to 9, so this will become 1 minus, this is 1 minus, no, not 1, this will become x raised to 5, 9 and 5, 12, yes, no, not 5, 9, 3, 12, right? So x cube minus 1, and here if you take x cube common, we will get not x cube common, here x is common, so x is common, this will become x cube minus 1, right, plus 1. Again x cube minus 1 will be positive here, because the x belongs to 1 to infinity. This is also positive, this is also positive, x is also positive, x raised to 9 is also positive, this is also greater than 0. So that means here the x belongs to real number, that is from minus infinity to infinity. So I think D option is correct, right? Now let's solve question number 29. So in the question number 29, we need to find domain. So as I discussed in the class also, this root should be positive and should be defined. So plus 2 minus x divided by 2 plus x root. So only we need to define the roots. So whenever root is defined, that will be our domain. So here x minus 3 divided by x plus 3 should be greater than 0, right? Greater than equals to 0, because root should be always, root is always defined for positive or 0 number, right? So again for this we can draw these roots on number line, that is minus 3 here, plus 3, this is positive, negative, positive, right? So x belongs to 3 to infinity and minus infinity to minus 3. So here we can not include this root, that means negative 3 is not included, positive 3 is included. So from this minus infinity to negative root union 3 to infinity, right? And also this should be true. So 2 minus x divided by 2 plus x, right? I have discussed in the class, if f domain of f plus minus g is intersection of d1 d2. d1 is domain of f and d2 is domain of g function. So intersection of d1 and d2. So this also should be true simultaneously. So let's make this first of all in standard form. So this is x minus 2 and x plus 2, because I am taking negative common here, so that's why this sign of inequality will get changed. Now draw a number line. So 2 minus 2 here, 2 here, because it is negative, so it will be negative between the root. So x belongs to minus 2 to 2. Here minus 2 is not included, but 2 is included. So now let's take intersection. This is minus 3, this is minus 2, 2 and 3. So this is 3 included to infinity, minus 3 to infinity, and here minus 3 again not included. So that means here also we have to make open interval to infinity. Again this is minus 2 to 2. minus 2 to 2. So minus 2 is not included, 2 is included. Again intersection is 5, right? So x belongs to 5. So if you will put any value of x here, this will, both root will not be defined at the same time. So here answer is this 5. Now solve next question. Here x square minus box x square. So again this is written, question number 30, this is written inside the root. So x square minus box x, right? So x square minus box x, first of all this would be 0, greater than equals to 0. So x square should be greater than equals to box x square, right? As you know, box x is always an integer values. So you can just draw the graph also for both the function, right? Also by using hit and trial you can find the answer, right? Like if you take here x equals to minus 2, so this will become 4 and this will become minus 4. This is also square is there, so this will become 4. So 4 minus 4 is 0. That means x equals to 2. If you take x equals to 2, this will become 0. So x equals to 2 is acceptable because root is defined. So like all the values, all the positive integer will be accepted here. So now let's check for another values. That means if you take minus 2 square and negative of box of minus 2 square, that is also equals to 0. You will get same values here. So that means negative integer is also included. Now only in one of the option integers are included here. So definitely directly you can say this is the correct option, right? Now see, so here if you want to draw the graph for this question, if you want to draw the graph, so this is the graph x square, right? And this is the graph of box x. First I am drawing the graph of box x. So this is the box x, graph of box x, right? Now if we are taking square of these values, so square of between 0 to 1, right? So you will get here 0, square between 0 to 1, you will get 0, square of 0 is 0. But square between 1 to 2, if you will take a square, box of square, so between 1 to 2 the answer is 1. So square of 1 is also 1. So you will get same value. Now between 2 to 3, if you take any number, the box x will give equals to 2 number, right? Square of 2 is 4. That means between 2 to 4 you will get a number that is equals to 4. That means you will not get this graph. So directly graph will jump at y equals to 4, right? So here you will get number as 4. On the same graph you can draw this graph here, right? You can draw this graph on this with this same graph, right? If you draw the graph here you will find, and this side also, see between minus 1 to 0 the graph is equals to minus 1, right? This one minus 1. So here you will get same graph as 1. So this is not included to 1, like this. So after this you will get graph. So this was directly you will get here between minus 2 to minus 1. Between minus 2 to minus 1 the value will be equals to 2. So directly you will get here 4, right? You will get this value directly 4. So both side, but graph of x square is like this. For x equals to 2 you will also get 4. For x equals to 2, square of 2 is 4. This is like this, right? here. So as you can see here, we need to find when x square is greater than this box x, right? So from this side, if you observe here, so the graph is, I can draw here more clearly. So now see, this is the graph. For x equals to 1, we have 1, right? So for x equals to 1, we have these values. So as you can see, this graph between this 1 to 2, this x square graph is above than box x. If it is above, that means this graph is value on this graph is greater than value on this box x graph, right? So this side from 0 to infinity, box x is always greater than, and this side, if you observe the graph here, so again we need to modify the graph because we are drawing on the same Cartesian plane. So this is 1. For x equals to -1, we will get -1, right? So graph will be like this. So for x equals to -1, square of -1 is 1. So this is 1, right? And square of 2 is 4. So you will get like this. So graph will be like this. This is the graph, right? So here the graph of this x between x to x minus to 0, between minus to 0, graph of box x was equals to this -1. Now it will be equals to 1. This is the graph. So at only this point both are equal. At this point both are equal. So here also if you draw the graph, you will get like this, right? So at this integral point, that is -2, both are equal. Otherwise this box x is greater than. So here overall domain of the function is 0 to infinity, and this side only integers. So also you can write down r plus union z, positive integer and negative z also. So this is the domain. So there are two methods which we have discussed here. Now question number 31, right? So it is root of log of 1 upon sine mod x. So here first of all, log should be defined, and this argument of log also should be defined, and that should be 0 to infinity. So because of this mod, because sine mod x belongs to 0 to 1, right? So for 0 to 1, this log upon 1 upon 0 to 1, 1 upon 0 to 1. So as you can see, for x equals to 0, this 1 over sin x will be not defined. Why? Because for x equals to 0, sin x is equal also 0. So 1 upon 0 is not defined, undefined term. So that means value of sin x cannot be equals to 0. First thing. For rest values of x or values of sin x, this mod will be defined, and this 1 upon mod x also will be defined. It will give some number, right? That will be from 1 to infinity. So sin x should not be only 0. So when sin x is 0, for x belongs to, x is not equals to n pi, here n belongs to integer. So for only these values of x, this sin x will become 0, then 1 upon 0 will be undefined, right? For rest values, because it is the 1 upon 0 to 1, 0 not included, already we have seen. So 0 not included, and this 1 included. So 1 upon 0 to 1, you will get answer 1 to infinity, right? So from 1 to infinity, log will be defined. If log is defined, then we don't need to take this inequality that log should be positive, because it is written inside the root. So from 1 to infinity, log is always positive, right? So root of positive number is defined. So only this is the value of, well, these are the values of x for which function is not defined. So here domain is r minus n pi, n belongs to z, right? This is the answer. So here which option is given? Yes, this one, C. Okay, question number 31 is also left. So now solve question number 31. So it is given log e of mod of x log e, right? So here first of all you can draw the graph of this one, this mod of log x. So now this is the graph of log x. If you are taking the mod of any function, so whatever graph is given inside below x-axis, you can take the graph of that portion with respect to x-axis. So the graph will be like this. Okay, for these values of x, as you can see, this is 1 comma 0. For x equals to 1, log, this log will become 0, and log 0, so for this log 0, this log is undefined, that is log of 0 is not defined. So this log should not be equals to 0. Value of this log should not be equals to 0. Why? If this log is 0, then this log will be undefined. So that means this x equals to 1 is not acceptable. Any other value of x we can take here, because for any other value of x except 1, the graph is positive, this graph is positive, graph of this log x is positive, and log of positive number is always defined, right? So that means here value of x belongs to 0 to 1 union 1 to infinity, right? 1 is not acceptable, 0 is also not acceptable. For x equals to 0, it is going to be infinity. So yes, D option is correct, 0 to 1 and 1 to infinity. Now solve question number 32. So for question number 32, domain of fx, root of minus log x minus 1 with base 0.3 and divided by x square plus 2x plus 8. So for this, first of all let's take discriminant. So 4 minus it is negative, 4 minus 4 into 8, so it is negative, that means this is always positive. So there will be no effect of this expression on the domain of this one, because this expression is always defined for x belongs to real number. So this is always defined, so only this root should be defined, this numerator should be defined. So only we are finding the values of x for which this root is defined. This is 0.3, so root should be defined. So this minus of log 0.3 x minus 1 should be greater than equals to 0, right? So greater than equals to 0, so we are removing negative sign here, so this will become less than 0. So log of x minus 1 with base 0.3 less than equals to 0, right? Because base is between 0 to 1, this base is less than 1 or greater than 0, this base. So here we can write down this x minus 1, inequality will get changed. So x minus 1 greater than equals to 0.3 raised to 0. So x minus 1 greater than equals to 1, right? This is 1. So here x is greater than equals to 2. So for x greater than equals to 2 only, this log will be defined. So here our domain is 2 to infinity. Yes, D option is correct, 2 to infinity. So 33, here 34. So here the question is log to the base 1 by 2. These properties I have discussed in the class, just only I am explaining you some problems. Minus 1, right? So first of all, this, because of this log, argument of this log should be positive, right? So here minus log base 2 1 plus 1 upon x raised to 4 minus 1, this should be positive number, right? 0 to infinity. So log of 1 plus 1 upon x raised to 4, right, minus, also you can take minus common and you can just send towards right side. So if I take minus common, this will become positive plus x. less than 0, it was greater than 0. Now I am removing the sign here, this will become less than 0 because previously it was greater than 0. So after cancelling out negative sign, this will become less than 0. Cancelling out means we are multiplying by minus 1 both sides, so the inequality will get changed. So this base is 2, so we can write down this 1 plus 1 upon x raised to 4. Because base is 2, inequality will remain same, so plus 1. So I think log is given up to this point. Let me check once again. Where is the question? This one. Yes, log is not including in this one. This log is up to this bracket. So we can write down here log of 2 with 1 plus 1 upon x raised to 4 is less than minus 1. Right? It is less than minus 1. So also we can write down because base is greater than 1, so we can write down 1 plus 1 upon x raised to 4 less than 2 raised to minus 1. So this is 1 upon x raised to 4 less than, this is 1 by 2 minus 1. So this is 1 by 2 minus 1 is minus 1 by 2. So here 1 by x raised to 4 is less than minus 2. This is not possible. Fourth root of x always will be positive number, and it is saying this should be less than or equals to negative number. That means all the negative numbers. So this is not possible. So x belongs to 5 here. So yes, D option is correct. Now next one, question number 35. Here the question is given q square minus 4pr equals to 0. Here p is greater than 0. Then the domain of the function f of x equals to log px cube plus p plus q x square plus q plus r x plus r. This is the expression is given. So the question is find the domain of this expression. Here it is given q square minus 4pr is equals to 0. So we need to find domain. That means argument of log should be positive number. First of all, this one. Okay. So and this q minus 4pr should be 0. So here let's write down px cube plus p x square plus qx square plus qx plus rx plus r. This should be greater than 0 number, right? So can we use any type of expression where we can utilize this q square minus 4pr, or q square is equals to 4pr? Okay, let's see what we can do. Here also rr q p. So previously it was written p. Suppose if we take px square common, right? So here we will get x plus 1. So if you take here qx common, so this is x plus 1, and here if we take r common, so here also it will, yes, now we will get the answer. So x plus 1 is also common, so px square plus qx plus r greater than 0. So let's find out discriminant of this one. So discriminant is q square minus 4pr. So that is given equals to 0 in the question. That means this equation have 2 roots. So this equation has 2 roots. This quadratic equation has 2 roots. If we put that root here, whatever root is there, so by putting that root in the expression, this expression will become 0. That means that root is not acceptable. We cannot put that root in the expression, whatever root is there for this quadratic, because we have equal roots. Why? Because discriminant is equals to 0. So again we have this root also, right? So we can write down, this is a perfect square, like x plus 1 whole square, x minus a whole square. Suppose a is here, plus or minus a, whatever, here is minus 1, right? This is also positive, this is also positive, this side is negative. This is not acceptable, this root is also not acceptable. So here x belongs to this minus 1, and let's find out the root also. We can find out easily just using the formula. So the root is minus q plus minus this root d is 0 divided by 2a. So that is equals to minus q by 2a. So this one is also not, this is minus q by 2a. This is also not acceptable, minus q by 2a. So let's find out the root, because this should be positive. So minus 1 to this root, minus 1 to q by 2a, right, union minus qa by 2a to infinity. This is the answer. Let's check the options also here. So okay, it is given r minus something, so you can subtract, you can write down using r also. R minus this root you have to subtract. This is not solution. So minus infinity to minus 1 is also not solution, so subtract this one also. And also there is one more value, that is minus q by 2a. This is option. So which option is correct? R minus 1 to 1, this one. Yes, union, this one is correct. Here it is, they are using intersection, here union is the correct answer. Now question number 36. Equals to minus log x plus 4 by 2 of log 2x minus 1 3 plus x, right? Because here variable is involved in the base, so we have to make two cases. When x plus 4 by 2 is between 0 to 1, when x plus 4 by 2 is greater than 1. So case 1 is x plus 4 by 2 is between 0 to 1, right? So this is one of the case. So when this belongs to 0 to 1, and also this minus log 2x minus 1 divided by x plus 3, this should be greater than, and with base x plus 4 greater than 0, because it is written inside the root. Now let's solve both. This is a fixed number 2, you can send towards both sides. So 0 greater than x plus 4 less than 2. So here x is less than minus 4 and greater than minus 2. So here x belongs to minus 4 to minus 2. So if x belongs to minus 4 to minus 2, right, then base will be between 0 to 1. Now, and this also should be true. So for this one you can write down, you can multiply by minus 1 both sides, 2x minus 1, x plus 3, here x plus 4 by 2. So this will become less than 0. Now if base is between 0 to 1, so this you can write down 2x minus 1 divided by minus 1, 2x divided by x plus 3. So base is less than 1, sign of inequality will get changed. So this will become x plus 4 divided by 2 raised to 0. So this is 2x minus 1, x plus 3 greater than 0. So 2x minus 1, x plus 3 minus 1 greater than 0. So 2x minus 1, x plus 3 minus x minus 3 greater than 0. So this is x minus 4 divided by x plus 3 greater than 0. So for this expression you can write down the solution here. This is minus 4, this is plus 4. Greater than means inside the root is the answer, sorry, beyond the root. So minus infinity to minus 4, union 4 to infinity. Both roots are also not included because equality is not there, right? So this answer. Now let's take the intersection between minus 4 to 2 and this solution. So from case 1 we are getting overall solution minus 4 to minus 2, right? And here minus infinity to, this is case 1, we need to take intersection, right? So let me check once again. We are getting here intersection as 5. this is also 5. Let me check once again. There was a property here I am using, log of b with base a if less than 0, right? So if a is also between 0 to 1, so you can write on b inequality will get changed, b raised to, here it is c suppose, so a raised to c, inequality will get changed because a belongs to between 0 to 1. So same thing I am using, previously it was less than 0, so here because base is between 0 to 1, I have changed the sign of inequality greater than 0, this will become 0. So this will side minus 1 minus x minus 3, so this is minus 4, x minus 4 divided by x plus 4 greater than 0. Okay, I hope I am correct. So here x belongs to 5. Now let's see case 2 also, right? So for case 2, so now this time x plus 4 by 2 is greater than 1. So that means x plus 4 is greater than 2 and x is greater than 2 minus 4, that is minus 2. So if x is this one, so again we can just pick the same expression here, this expression. So 2x minus log x plus 4 by 2, 2x minus 1 divided by x plus 3, this should be less than 0. I am just picking the same expression from here and we are following same condition like this. So here this would be less than 0. So this 2x, because this base is greater than 1, so inequality will remain same, so less than 1, right? This base raised to 0, so that is 1. Here also I have used same, yes, this was greater than 0, here it is less than 0, yes. So we will get same expression x minus, here we will get x minus 4, right? X minus 4 divided by x plus 3. Okay, this was 3 not 4, yes, we got it. This was plus 3 not 4, this was plus 3. So here this is minus 3. Now let's see this one. Okay, this is not, so this one, let's correct it. So x belongs to, no, just draw on number line. So one of the answer is minus 4 to minus 2. So next answer is 4 to infinity, here minus 2 to minus 1. So here one of the answer is minus 3 to minus infinity to minus 3, right? Minus 3 to so let me try it on again. That is 4 to infinity and minus 3 to minus infinity to minus 3. Second one is 4 to 2. So yes, this is intersection. So here x is not 5, x belongs to minus 4 to 3, open, minus 3. This is the value of x from case 1. Now let's find from case 2. So this is less than 0. Now let's draw number line. This is minus 3, this is 4. So 4 to infinity, minus infinity to minus 3. So here also let's draw the same value on x-axis here on the same line also. So this is minus 2 and answer is greater than minus 2. So minus 2 to infinity. So overall you will get this intersection, that is 4 to infinity. So now from this is solution 2 and this was solution 1, right? So now we have, because there are two cases, so in cases we have to add, that means we have to take union. So S1 and S2. So minus 4 to minus 3 union 4 to infinity. This is the answer. Which option is correct? First option is correct. So 37. Okay, try this problem based on same type of problem. Okay.